Okay, today we're going to do our Unit 7 notes number 1. So this is going to be a new unit that talks about our exponential functions. So first we're going to go over what an exponential function looks like, or what it could look like, and what each part means. So first we're going to talk about our a, b, and d values. So the a value, so if there is a number in front of our b, which is our base, the a value stretches or compresses the function vertically. So this is whether it looks smashed or not smashed, pretty much. The a value also will reflect the function over the x-axis. So if there's a negative in front of that a, it's going to have a reflection. The d value, which is our value on the end, so if we're adding or subtracting, is going to shift the function up and down. So if you're adding, it's going to shift it up, and if you're subtracting, it's going to shift it down. And then our b value is our base. So that's going to pretty much typically stay the same, or that's going to kind of tell you a little bit about your function. So there are many different exponential parent functions. So like quadratic, our parent function is x squared. Well, we're exponential, whatever our base is, each base has a different parent function. So there are many different exponential parent functions. Each different b value has its own parent function. We're going to talk more about that. So going down, our first example says write the parent function with a base. So this is our base. So we're going to have y equals, we don't have an a, so 2 to the x. Next one, our base is 1/2. So we're going to y equals, we're going to put 1/2 in parentheses to the x. Next one, we're going to have y equals 5 to the x. And the next one, we're going to have a fraction again, so we're going to make sure we put it in parentheses, 1/3 to the x. Okay, now let's go down and let's start graphing these. So the first one says use a table to graph the parent function y equals 3x. Then identify its key characteristics. Okay, whenever we are identifying these, or whenever we're graphing, we're going to plug it into our calculator and get our table. So I hope you guys can see this. I'm going to go to my Desmos graphing calculator, and I'm just going to type in, let me exit out of those ones. So I'm just going to type in y equals 3. I'm going to have to find my little caret symbol. Okay, well, it's not going to show me my caret symbol on my keyboard. To the x. And that's going to give me my function. So it has that L shape. And if you click on this gears thing and then hit table, it'll give you all of your points. So some of these points will be like 0.11 and those you can put into the calculator and get them in a fraction if you need to. So that's going to be my table. I'm going to write this on my, so off to the side so I kind of have a view. So x, y, again, we're going to use -2, -1, 0, 1, 2. So -2, it had 0.11. That's actually 1/9. If you put a decimal, that's fine. 1/3, 1, 3, and 9. So we're going to graph those points. So -2 1/9 is going to go over 2 and about up 1/9. So up just a teeny bit. And then -1 1/3 is going to go up just a little bit more. So try to be as precise as you can. Just make sure they're in that range. 0 1, 1 3, and then 2 9. So those are our points, and then we're going to graph our length. So it's going to graze the x-axis and then go up. So whatever that lowest point is, it's never, so since it's like at like 1/3, 1/9, it's going to keep going low, but it's never going to go below 0. So it's going to graze that y at this x-axis right here. Okay, now going over our characteristics. Y-intercept, where it crosses the y-axis, right here, 0 1. Our horizontal asymptote is basically what line does it get super close to, but it never crosses. So like this one, it gets super, super close to y equals 0, but it never goes below it. It just grazes this line right here. So our horizontal asymptote is y equals 0. Now this one, growth or decay. So growth, it's increasing. Decay, it's decreasing. So this one we can see that it's going up. So it's growth. Now if you guys remember, our domain is our x and our range are our y values. So on this one, our x values, it's going to keep going in both directions forever. So it's going to be y, or it's going to be all real numbers. And then our range, it never hits 0, but it keeps going up on the y-axis. So it's going to be y is greater than 0. So your horizontal asymptote and your range, those numbers should match. Now, whether you have a greater than or less than sign on your range will depend on which way this function's going. Okay, let me know if you guys have any questions on that. We're going to go to the next page. Okay, so we're going to plug this. So it says use a table to graph this. So we're going to plug this function into our calculator. So if we go back to this, so I am going to switch this to 1 divided by 2. So this is what it looks like. So if you guys didn't, so kind of realize if our base is a whole number, it's going to be growth. If our base is a fraction, it's going to be decay. So that's to kind of keep that in mind. Oh, and then I need to get my table. Forgot about my table. Okay, so this is going to be my table. So I'm going to have -2, -1, 0, 1, 2. And then I'm going to put that on my graph. So x, y, -2, -1, 0, 1, 2. So at -2, we were at 4, and then 2, and then 1, then 1/2, and then 1/4. I was trying to draw that line. Okay, graphing this. So -2, 4. So over -2, up 4. -1, 2. 0, 1. 1, 1/2. So right in the middle, and 1 and 2, 1/4. And then I draw my line. So it starts right here, it goes down, and it because it gets super close to that 0, y equals 0, but never crosses, that's where the line is going to graze. So our y-intercept is 0, 1 again. The horizontal asymptote is that y value it grazes. So it grazes 0, but it never crosses. Because this line is going down, it is decay. Domain is going to be all real numbers since it's our x value is always decrease. So now our y. So our line is bigger than 0, so it's going to be y is greater than 0. Okay, let me know if you guys have any questions on that. Let's go on to the next problem. So it says match either of the functions to the graph. So this one, you just really need to type each of these into the graphing calculator. So this one, I'm going to have y equals 2 to the x. I'm going to have y equals 1 divided by 3 to the x. I'm going to have y equals 4 to the x. And y equals 1 divided by 5 to the x. Okay, so this first one, let's change this color. Okay, let's change it to red. Okay, so these ones are all kind of similar. So the first one, y to the x, is this green one. So which one's going up? And then it goes out. So the one that goes out the furthest. And you kind of pick your points. You can kind of look at your points too. So this one hits at 1, 2, and then at 2, 4. So 1, 2, oops, crap. This one hits at 1, 2. This one does not, and those two are both decay. So A is going to go to this one. Cross that one out. Okay, B, let's go back to our graphing calculator. We have 1/3 to the x. This is their thread length, so it's going down. So it looks like it crosses at 0, 3, and then -2, 9. So 0, 3, so it'd have to be this one. So this one would be B. So you're going to try to look at not only where the y-intercept is, because these all have the same y-intercept, but where your next points kind of meet. Next one, 4 to the x. This one, I think, is the other. So 4 to the x is the other growth one. So this one hits at 1, 4. So this one also hits at 1, 4. So this one would be C. And then our last one, it should hit at -1, 5. So let's make sure. So this one, our black, it hits at -1, 5. So this one would be D. So this one you're going to have to really utilize your calculator for. And you guys can also graph this on your graphing calculator if you don't feel comfortable with Desmos. Okay, we can tell that a point lies in a graph of an exponential equation if, when we plug in the values, they make the equation true. So that's how it lays on the line. Now, on these, I am more than okay if you were to type this into your calculator and get your table. But I'm going to show you both ways. Either show your table with those points on it or plug it in. So this first one, I'm going to plug in -9 for y because this is my x and this is my y. So I'm going to have -9 equals -3 to the second. Now, -9 equals -9 because -3 squared is -9. So this one, oh my God, that looks really bad. So this would be true. So this one is a solution. Now this one, I'm going to do my x, y. 3 equals -3 to the -1st. So this equals 3 equals -1/3. Because anytime we have a negative, we flip it. So this is false. Now, if you go to your calculator and you put y equals -3 to the x and hit your gear button to get your table, you would get, so this would be 1/9. So we know -1 would give you a fraction as a y, but 2 would give you a -9. So you could also copy down this table. So if I have my x and my y, -2, -1, 0, 1, 2. You plugged in -2. What did I get? -2 was -1/9. This is -1/3. -1, -3, and -9. So I would also be okay if you show your table. So -2, -9 is on there, so that's true. But -1/3 is not on there, so there is not true. So keep that in mind. Okay, let us know if you guys have any questions. Please refer back to your notes as you guys are working through your homework.